Hello, welcome back. So, okay. Let's continue with Runic here. Last time, I believe, yeah, we started on 4 loops. And I think we got pretty close, but there are some fundamental issues right now with the closures, from what I remember. Yeah, here we go. So labels have the wrong address of the closure. So basically, because the closures are like compiled in a weird way. So it's like we're inserting instructions. So basically how we're calculating a label address is that we're basically just checking how many instructions do we have right now. However, then we have closures that actually adds like instructions after the fact. So you might be getting an offset that is wrong. So we have to figure out how to solve that issue, because I think that is perhaps one of the... Yeah, we really need to fix that issue. However, I would like to actually check the compilation, or to check the implementation of the for loop. We can do that anyway, because we can just adjust the address manually for now. So if we look at this, we have a label 4.1, which is wrong. It should be like down here. Or yes, it should be down here, yeah. So that's where the label should be. So we basically just need to adjust it by 2 here down. So if we go to the for label, we move it down 2 instructions, and it should be correct now. Just reminding myself that there has to be a thing there. So now we moved it 2 steps down, and if we compile now and look for this label, we can see it now is correct. It's at the compare, like it's checking, you know, if the for loop should exit or not. So let's see if this works. No. Okay. Let's see where we end up being wrong here. Whoops. Let's see. 1, 0, 1B. So this is kind of the same place, I think. So set. So breakpoint. Okay, so I think that from here it should be fine. If we look at the stack, we have this is the counter for the iterations, and this is the number of iterations, and then this is the like the iteration like binding element that will have the value of the iteration. So now, okay, so we still have the correct thing. Hello, Gilukt. How? So okay, are you making a shell too? No, I'm not. I'm only making like the scripting language. Let's see. So yeah, so this is correct, I think, but these are correct, so and this is correct, this is correct. Okay, so when are we getting an issue here? Everything seems to be in order. Wait, we get back here? Okay, this seems wrong, I think. Yeah, so that is strange. It goes back. I mean, yeah, it could be that this label is also wrong. The 4 label is wrong as well. Okay. So I think we need to add 2 to this as well, because this is wrong. We should have like labels, and then get, no, let's just get, here we get the pointer. The key is gonna be the label key. I think that is, yeah, label key. And then I'm gonna get that. A pointer to an optional. So basically, we know that now it's not optional anymore. So we can simply set this to be plus equal to, I believe. So we're basically manually temp code remove when closure fix is done. Okay, so we basically just manually change this. Invalid operands, binary expression, optional. Okay, excuse me. Actually, let's do this. Yeah, I believe you can do something like this. It looks really strange here, but basically this is a pointer to an optional. So we dereference it to get the optional value inside there, and then we're saying if, so we want to modify the actual value in the pointer here if it's not optional or not null, I mean. So then we get this, which is a pointer now to the place we need to modify. Okay, I think that should work. For after. Yeah, okay. Yeah, that looks actually correct, because this is like the loop back to the for body, and this is the after, where after the thing has the loop is done, which happens to be exiting, because that's the last thing that's happening. Okay, and there we go, except we don't go, because the last one didn't. Okay, so let's see, continue. So we look at the stack, we have void 0, 3, okay? So we compare, of course, that should be good. We allocate. Capture. Okay, so the capture hasn't actually been populated yet. So there's some order of operations issue here. Yeah, here's the compare and jump. So here's the capture. Oh, I see. Wait. This, I think, okay, so I think this, we have to do this first. Then, and before we do this, okay. I think. Okay, there we go. Hello, Paul. What's up? All right. Okay, so there we go. I mean, yeah. Okay, so this confirms that basically the for loop works. Let's try a block as well. Okay, this. Wait, expected value, actual L brace. Strange. There's a parser error here. Okay. I'm confused because that has worked before, I'm pretty sure. Okay, but let's where is that? Parse 4. So body is just parse expression. That should include brace, like a block. What are your plans for today? What are you gonna code this ring? It's gonna be runic. But yeah, I think I wanna do like runic until it's done now, unless it takes like forever. But I just want to be done with it. So I'm gonna work on runic. The thing is that there's not that much left on it. I just wanna tick it off as the first version and move on there. And once that's done, which I'm not sure how many streams that will take, I will do some game development. Go back to game development. Oh, I see. Yeah. So what more specifically in runic? So right now I'm working on the for loops. So this one here, and it did work when we had it like this. So this actually works. We got an array with 3, 4, 5, and then we're iterating on that array. We're capturing each element and we're echoing that out. So that works. But when I try to do the block thing here, it doesn't work because there's some parsing error. So I'm looking into that. This should work, but I need to look at why this is not parsing correctly here. Because we have the capture. So what I can do is well, we don't need enable IR, but we can do like runic parser or log parser equals 1, and then we get some more information here on what paths it takes for the parsing. So of course here we should be when we have the for keyword, it should be doing like a for expression. Yeah, parse for expression. And then it's doing all that. Parsing array. String or strta. Oh, strange. So I thought you were quoting, or yeah, I thought you were listing like or saying like some kind of C string function. But I think you meant to say strange. Though if else blocks work. Yeah. So, but they have like different parsers. But I know that for loops, they should. I mean, they work in other form. They are being parsed in other forms. It's just I think maybe I've never tried this exact form before. So I think it's probably not that huge fix here. I just need to see where the issue is there. So yeah, so here it's doing like the capture clause, and there's the end of the capture clause, I think. So how you read this is basically this orange thing is where I think is where the token is right now, and then the purple is where we have peaked ahead to see what comes ahead. So here we have like an optional capture clause. Of course, that looks at these pipe symbols or characters, and then we have binding pattern inside there, which should be correct, and then it goes back to parsing an expression. Parse expression. Why would it go to parse expression there? That is strange. It's like we never consume this token here. Or maybe the binary expression does not support the brace. Maybe I broke this before, actually. Yeah, because if you see here, like it parses a capture clause, which should work, and then it parses the body, which is just an expression, and this could be either, it could be a block expression, it could be a binary expression, it can basically be anything, any kind of expression, really. And then it goes. I mean, we can see that it went into binary directly. Which is kind of strange. I mean, or maybe not, because it goes in here. Yeah. Oh shit, this is a really old. This should be binary here. Because I started out with only arithmetics, but now it's like all kinds of operations you can have. Also, the LSP seems to have given up here. There's like some files, there's something that it doesn't like, and I don't know what it is, and I can't like go to this definition here. I can, funnily enough, I can do like space and go to type definitions. That works for some reason, but not go to definition. I don't really understand how that works, but yeah, I'll take it. Okay, so this one is really complicated, this function here, but basically, if you look at here, it basically just says that, okay, well, we've got an L brace, so that's an unexpected token. And I did take away this because I wanted these to be able to be part of binary expressions. So L brace shouldn't be like an error. But then it should also be one of these value types then. So actually, let's say we have an L brace. That should just be a block, and wait, expression. Maybe it's just gonna be like an expression actually. I don't, wait, are expressions even used? Yes. Okay, so for parentheses. Yeah, we'll probably just have it as an expression probably. So we could use like L brace here as well, I guess. But then this changes. Okay, let's do this. Let's move you up here. And yeah, sure. Let's add a breadcrumb here. Is that correctly spelled? I don't know. We'll take that and we'll parse a block expression, which just, yeah, it parses a block. It expects an L brace, parses until L R brace. I think that should work. Oh, here's, see, the LSP actually does work. Have you shut down your website? Not manually. It might have gone down. To be honest, I don't really check that much. Oh, it seems to be down. That's strange. Let me just check that real quick. Okay, the server seems to be running. Hang on. Let's see. For some reason it has, maybe it like restarted or something, because I haven't set up so that it actually like restores anything on startup. So let's do. Okay, now it should be up. Thanks for telling me. It worked like 2 weeks ago. This week again, I found it. Yeah, okay. I suspect that somehow the server may have restarted or something. I should really put like a script or something that starts that also starts the server when it starts the web page and all that when it's. Okay, anyway. Okay, well, the LSP doesn't complain anymore. Great. Interesting. Now we get unsupported waiting. 038. R is set to thread 4. Wait, that should be correct. So, right. Oh, okay. Now we get something here. So this should fail. Okay, yeah. Okay, so R is set to 14 for some reason. Thread 0. Yeah, now it's up. Yeah, great. You are my monitor. I don't really look at that too much now because there's not much. I mean, there's not much happening there. I'll probably post something when like the first version of Runic is done. Yeah, so what are we pop here? What do we pop here? Okay, actually, let's put a breakpoint at 36 instead. Okay, I think there might be closure issues, maybe. You know what? Before we do this, let's actually just, because this works, right? But if we introduce a block, that actually adds like a bunch of closure stuff. So we might get the wrong alignment for the labels. So if we, for example, if we run this, so 4.1 should still be correct. Yes, that is correct. But after might actually not be correct. Oh, it is correct. Okay, so that was not the issue. Okay. That was actually not the issue. Interesting. Oh yeah, probably because the closure was already compiled. And this instruction address was set after that, so That would have been correct. Okay, maybe it's just the initial closure then that is the issue. And potential, I guess potential loops inside here as well. Yeah. But okay. Well, okay, so what I wanted to do was fix the closure issue first before tackling this, but I think that it's not actually an issue. We could tackle this issue here. So yeah, what was it? Breakpoint 36. Okay. So what's on the stack right now? We have pointer to 9 and then thread 4. So thread 4 is what we're waiting on. And next time around we have... Oh, I see. We have like a lingering... We have a stack balance issue. Because this void here should be cleaned up. Okay. Interestingly, this only happens when we introduce the block. Okay. Did you commit the repo for 3 months? Do you use some version control? Yes. So I'm actually working like on a separate branch right now. So that's why it looks like that. If you go to the if you look at branches, and then you go to the IR branch, that's where I'm working right now. Because once that is basically stable, and once I've well, maybe not stable, but once I'm not sure if this language ever is going to be stable, but once I've basically gone I think after 4 loops I'll probably merge IR to take over, because then I've covered all the... It's basically when this file here is compiling and running. This right now runs like, if let's say we run it with the old version. So then you would do runic MVP. So this is running with the old version. Also, it's super slow. But if we run it with IR, there's a bunch of issues. So yeah, I need to fix those, and once they are fixed, I will merge. Basically, once this MVP.rn is runnable with the IR version, then I will merge. It's kind of like the tests suite right now for all the features and stuff. Yeah, there is a lot of merge, but I mean, there won't be any. I mean, I'm the only person working, so there won't be any conflicts or anything. But but yeah, there's a lot of things in the IR, because it totally. I'm basically throwing away the old interpreter and making I've made an entirely new interpreter that will and compiler, like, that's entirely new. So yeah, there's a lot of changes. Basically almost like rebuilding everything except the parser and the lexer, basically. Although I did have to make some changes to it to fix this thing. But these are the things that I'm working on right now. So once the for loops works like this, I will merge IR in. But then I also want to add a couple more things before we have the MVP version, like redirects and like logical operators for like executing. You have like echo, hello, and then and like this. Oh, and something else, I don't know. Like these kinds of operators. So these are not in the MVP file right now, but I will add them later. So there you go. So let's go back here and figure this out. So why do we get an issue here? And only on the... Yeah, okay. Now I remember. So there's a stack imbalance issue. Let's just investigate the block. So we create this pipe. And closure. Fork. So basically the issue is that, well, we're pushing something to the stack, but we don't pop it later. So then there's an imbalance issue there to get back to where we were. And that messes things up later on. I mean, we could also just debug, go through it to see what's happening, but I just wanted to check here real quick. Source. Wait. Pop. So I believe the closure will take care of itself. These, though, the pipes, this thing, and this thing. Yeah, okay, so maybe those two are... Where are those taken care of? No, this is... Okay, no, this is inside the other set, so that doesn't count. I think it might be this thing here. This thing is messing things up, I think. Probably. Or no, wait. Yes? No? Yes? Yeah, I think we want to pop that then. But the thing is, like, this is just R. So I think before we pop, we want to say, we want to save R. So we're going to do set R2 to be block results, and then we pop, and then we restore R to R2, and then we return R. Okay. Because pop overrides R, so I wish maybe I should have changed these to not like always use R, because it just, I mean, sometimes it's like, yeah, okay, it's one instruction to do two things, but yeah, but it would be cool if we could say that pop stores it in an arbitrary place instead. And so then you could say here you would like, you just discard it into R2 or something, or into nothing as well. Maybe that could be an option as well. Expected type, oh yeah, so it needs to be from. Okay. Value of type. Yeah, we don't care about you. Okay, so I think that should restore, because this block standard out. This is pushed here, but it's never popped. So, okay. Hey, there you go. Oh, sorry, I'm getting a call here. Be right back. All right, sorry about that. There's a lot of stuff happening at work right now. We'll see what happens. All right, so 3, 4, 5. Yeah, so okay, so that actually works now. But I have a prediction. I have a prediction that this would not work. Because, and the reason for that is because of the closures. The closure compilation is weird, and now I think all hell will break loose. Yeah. Could not the reference value of type u integer. So if we look at where this is happening, 425. Yeah. So actually, you know what? We can even just look at the compilation and look at four. I guess 2. Wait, 3. That's strange. It went from 2 to 3. Oh, maybe it was the label or something. So we can see that this label is actually here, which is way off. This is not the for, the for loop over here. So yeah, so that is what we need to fix in order to fix this. All right, see you later, Paul. Thanks for stopping by. To fix this, the nested for loops, we have to fix the closure compilation to not mess with the instruction addresses. So, all right. So that is what we need to do. What I'll do is I will go to compile 4 and we'll restore these to where they should be. And I'll remove this temporary code. There we go. Okay, so now they are where they should be. However, the calculation is wrong. Now comes the question, like, how do we actually solve this? Because So, okay, let's start at compile main, or yes. So here's the initial compile. So basically, this closure just adds 2 instructions. So really, we could just adjust. We could have like an adjustment happening, maybe, that adjusts the number of instructions. I'm not really sure how to do this. Another way would be to have all the closures be compiled in a separate set instead, because then they wouldn't affect the current instruction set at all. And we would have like a pre-closure setup. Actually, would that work? Yeah, it would work. It would work. It's just that it's a little bit annoying. So I would like to find another solution to this, but I guess maybe it's not possible. We could also have like a post fix thing. Let's say you have a set. So basically how the instructions work is basically we have a bunch of sets of instructions, and each instruction set is a list of instructions. So it's basically a list of lists of instructions. So it's not just one long list of instructions. We have a list of lists of instructions. So they are live in separate islands, you could say. Hello, Aryan Singh. What's up? Welcome back. And yeah, we could just do that. It's gonna be over here though. This one is going to be this only has like 2 though. And so it's like we could actually, you know what? Maybe no. The issue with the other closures, so this closure we always have 2 instructions, so that is easy to fix. However, the other closures have like a variable number of instructions being inserted, so that's a bit trickier, I guess. But here, what I was thinking, like the only thing that we need to kind of do after the fact is we need to see how many closure items we need, and that this is the only thing. This is the only variable that we need to kind of modify after the fact. So actually what we could probably do is we could add this instruction, and then later we just go in and modify this instruction after to be this. And then we would avoid everything there. But then for the other closures, like for this, as for these normal closures, since they have like a variable number of instructions, it doesn't really work. We have a for loop here with a variable number of instructions. So for this one, it doesn't actually work to do that. But let's try doing this. Let's try here first. I'm gonna do this pattern here first. So I'm not gonna create a list of instructions. What we're gonna do is that we are going to create, well, actually, you know what? Let's add, here we'll add like instruction set. So this would be the number of the set that we're supposed to put this closure in to. Okay, so let's say we get this, and now we say instead of creating this list of instructions, I'm just gonna do this. What we're gonna do is we're gonna set our instruction set to be closure instruction set. And then later we will restore it, so we have to have the original as well. Okay, so while we have this as a instruction set, now we can just add these instructions here. So this would be alloc CL. And it's also way simpler now as well. We do have this source. Size would be CL. So there we go. Now we have that. And then we have set stack 3. So that's just a closure, basically. Set stack 3 to be from location register R. So basically, yeah, R is going to be whatever alloc is returning. We're setting the closure to point to that pointer. Okay, and that's it. And then this is a special instruction set. Now, also what we need to do is we need to also jump back now. So we actually need to jump back to the original set. So condition is so it's unconditional jump, and this one doesn't matter. Destination, I think we should have the destination here. Return address, probably. Okay. So it's a little bit cleaner compilation, but But we do get another instruction set, so, but whatever. Okay, now we also need to modify this to return the proper stuff. Where's the thing? Yeah, here's the closure. Create compile main closure. So yeah, I mean, return address, get address, I think, but this one is resolved. Where was that? Jump. You need an instruction address. Structure size, local address, local. Oh, I see. This has an actual number here. Current address. Get local address. Can we turn this into the other? No. New label. Okay, I guess we can just make a label. I guess we can do that. I forgot how this worked. Obviously. Okay, let's do that. Let's just create a label here. Return address is gonna be new label. Main closure return. I believe we can just say abs there. You need to be try. Yes. So that's the return address. And what else do we want to have? Instruction set, right? So the instruction set actually, yeah, we actually want to create a new instruction set. So new create, wait. Instruction set, no. Instruction set. Add instruction set, there we go. All right, there we go. So that is then returned over here. Yeah, because the index to where it wanted the things to be is here, and then we return there. We just have to make sure, like, where do we actually jump now as well? I think we just jump here. Yeah. And the index is no longer needed, so we can just return or remove that. I'm just gonna comment it down. So we're gonna have a jump because this is the point where we should jump and actually create the closure. So we'll jump unconditionally into the new set. So that would be instruction set address 0. Right. There we go. Okay. So that should do that. We could try this out. Let's open up like main closure here. And this basically, does this compile? Yes. Yeah. Okay. So we should get to, well, okay, we got a lot of sets actually. What's happening over here? Oh, it's calling this as a thing. Okay, now I thought, okay. There we go. We just have a, okay. So actually, yeah, we have these sets, which are the streams. We have this set, which is the closure, main closure creation thing. I think I want to align those a little bit differently because we might have hard-coded these things. We might have hard-coded the number of those sets. So I just want to restore that number there. There we go. So now it's set 1, 2, 3, and then we have set 4, which is this closure initialize thing. So we don't have anything in the closures. We alloc 0, and we jump back to main closure return, which is over here. So basically, this jumps into 4, set 4, and then we just jump back over here, which continues execution. So that looks correct. Okay, so we can actually do the same thing now with the other closure. Also, I want to try now, because we did restore the for loops. Yeah, so this works now properly, which is really cool. But this does not work because we haven't done the normal closures yet. So I will see how we can do that now. So we'll start with going up to this thing. So closure context. So we don't need index. It's gonna be sort of the same thing now, but I don't know if we need 2 places we need to go, because there's a setup portion and then there's a cleanup portion. I think it depends if the cleanup portion is fairly static. Let's check that out. Where is that? It's over here. So this function creates the creation of the closure and the cleanup of the closure. We have pre-instructions that happens before a fork, and then post-instructions happens after. And there's no for loop in the post, so we could probably be able to just put these after the fork itself. I just want to make sure if we have anything that needs to be that is like known after the fact. I don't think so. What is this comment message? Oh, that's We put a comment in there. Okay. Hello Titsy, welcome back. How did the stream go yesterday, by the way? Set closure says, so this should be available. That's fine. And then we just have some pops. And then... Yeah, okay. So I think these instructions can be just added in a separate thing. I'm gonna say compile closure post fork. Okay. Although this would be a closure context. And so, do we really want to comment here? I mean, I guess. It's nice to know where the things came from. Okay, so instead of doing this, we do self comment. And comment message. Okay. And then over here we have set closure save R to be from location init register R. And then we have pop. And now we don't even need to deal with this anymore, which is really nice. Pop again. Cool. So that can just happen like afterwards. So that's great. And we can also now remove the post instructions. Awesome. All right. So let's see, and but basically we at all places where we use this, we have to now compile post, and we have to add it after the fork. So usually you have like compile creator and then a fork, and then directly after that we need to, oh shit, well, I need to figure out how to deal with this. Well, if we pop here, that should fix itself. Closure post. I have no idea why the computer is like refusing to do like auto completion. I did Zig yesterday, was fun but not simple to read user input. Not sure if I like that or not, but I understand now how it works. Oh yeah. The user input, yeah, I could have shown you to get you a little bit head start, because yeah, it's not I agree, it's not super simple to get into, but then once you learn it, it's what's good with this, with how they like how the interface work, it's very generic and works with any byte stream thing, but yeah, there's no like super simple way to just read something from the input. You have to dig a little bit, but that's also the thing with Zig, is that there's a lot of things with Zig that is like that. Because Zig is not like, it's not a released like language yet. You could say it's still in, I don't know if they consider it alpha or beta or whatever, but it's you know, it's still not fully kind of released yet. So you would expect bad documentation, basically, and you know, it's not fully complete yet as well. The standard library may change like in drastic ways. Actually, the next version they are gonna introduce like async stuff. Actually, let me check. Zig 0.16. When is this coming out? Wait, is it released? No, it's not released. Yeah, they're still working on 0.16, so that will also bring like some changes to major changes to things. Maybe for safety. Which part? So it would actually be interesting, because I know that I've made like a lot of examples here, but if I can actually remember how to do it. Why is this not working? Okay, I need to restart my mirroring. Okay, there we go. So basically, you would have first you need standard in file. So that would be like file system standard in. So even here, it's kind of it's like a little bit complicated, but I think they try to design it in such a way where you have these components that are supposed to work together. Yeah, it's very flexible. That is true. It's very you can do anything basically, but there's no like more abstract, more kind of, I guess, easier way to do it. But it's like when you learn how to do it, you can do it. So and then you need like let's say we have a standard in buffer. I'm just gonna do some arbitrary buffer here, and then we have standard in. Then you have like a file reader. So you do like reader, and then you supply the buffer. Now the buffer, I mean, yeah, the buffer isn't always necessary, but I usually want to have a buffer, so because there has been some weird issues when you don't supply a buffer sometimes. Right, so that's the reader. Now you can use the reader directly. Also, I think it needs to be mutable. And then say reader. Wait. What the hell? Where's the reader? Oh no, interface. That's right, interface. And this is like the generic reader interface. So here you can say something like take delimiter exclusive new line. So this would take until we reach this delimiter, and it should return a string. So this would be the input. Let's add a try here, and then we'll just log this out like this. You inputted, in lack of better terms, and then should be able to just run this. Yeah. So a lot of steps just reading a simple thing from the terminal, but it is very flexible. You can use this interface to do a whole bunch of different things. And also if you enable raw mode, so you don't have to like press enter to actually pass things into standard in, you can also do like more advanced things as well, like an actual a roguelike or something like that. But did you do, was your solution like this, or how did you solve the, how did you do it? All right. Sorry about that. Let's see. A couple of solution for Stack Overflow uses stream delimiter. Okay. Yeah, because there's a whole bunch of functions on the interface that you could use. So yeah, I think this is. I haven't actually used this, but you can stream into a writer, and what's nice about this, the writer could be anything. It could be writing into a file, it could be writing into a pipe, it could be writing into a in-memory buffer, you know. So that's actually kind of cool how they did that. And you had a line buffer thing. Okay. Yeah. I would actually, it would be cool to make like a roguelike sometime with Zig, because I recently, or now it's not recently anymore, but during my adventures with Zig, I actually learned about ANSI codes and stuff like that. So I actually know right now how to make a terminal, you know, based roguelike, just using standard in, standard out. So I don't know. I find it fascinating. Fascinating is the word, the pronunciation. Let's see. Where are we? Where do we go? How did we get here? Okay, so this, I guess we'll find out if it should work or not. But basically, here now we compile closure post fork. There we go. So that is now taken care of, although we need to add this basically at every point where we have this. So boom. Although this is stage closures I dash. And last one, oh, that's where we were there. Source last closure. Actually, what was this one called? Oh, so this is stage closure 0. Okay. But mostly these should be called just closure. So let's do that. Was that it, actually? That might have been it. Alright, cool. Well, I wanted to maybe make a game in terminal, eventually make it 2D or something. Ah, okay. I actually, yeah. So I actually did make a terminal shoot 'em up in Haskell, which also reminds me of this because it's like ANSI codes as well. But did you make it like at purely text based, like, you know, like sentences and stuff, or did you make like you know, you can move around a character on in the terminal? No field name index. Ignored. All right. Pure to text based. Okay. That is so like nostalgic. I feel like, because it's like the first like programming. Like when I started learning programming, I started learning like C++, and of course it was like, you know, terminal based at first. At that point, and it was always gonna be some kind of text adventure game. It's a good way to learn, I feel, because it's like a fun project, and yeah, you're practicing, learning. Okay, so now is the issues that we need to deal with. So I'm gonna not deal with pipelines right now because they are the most annoying of these. So I'm just gonna solve this right here. So we don't have an index. So what we would have though is I guess this would be the return address. Okay, 1 second here. I just need to. I just got a call here. All right, sorry about that. Yeah, as I said, there's like a lot of things happening right now at work, so. All right, anyway. We'll see what happens. Okay. Now the question is... No, okay, so the whole main thing it was I wanted to know if we needed multiple return address. We don't. So this would be the closure return address. And the index is gone. I'll just remove this here. These two we need, but we also need an instruction set that is going to be where we need to jump. And so the return address would be after that. So we have that, we have the, no, this would be like jump. All right, so we're creating a set, we're jumping to that, and then we return after that. Okay. Everything is stored over here, but we need to also add these things. Whoops. There we go. Okay. So now we have also this thing that we need to take care of. And well, same way now that the main closure was done. Let's do this. And we will figure this out. Sorry, it's I only got reading lines to work. I had a game like that before where you have your money, inventory, etc. And you can fight, get more money. It's based turn-based with some randomization, like Pokemon, for example. We can fight zombies instead of skeletons. Like, okay, are you talking about text-based, purely text-based then, or that you can move around, like in like you know, like Rogue? Okay, so yes, so let's, okay, we'll do the comments. They should be the same, but then we just do comments. Actually, you know what? Yeah, okay, yeah. We also need the original instruction set, and we set that to the original back, and then at the end we will do a jump to the return address. Awesome. That's the commit or the comment message. I mean, here we set. So we set closure save or to be from location register R. We might actually be able to get around that because we have R2 now. We'll see. So alloc2. Wait, not alloc2, allocCL. And then we set closure ref to be from location in register R. And here's the loop, so we need to loop through all of those. And we'll do set what. Set destination, set add register R. We add I, the reference true, and we set that to look up plain kosher items I identifier plain shallow true. Initial depth. Wait. Is that it? Okay. And last we have set or to closure saved or the address. We don't need to say location there. Okay, so this is the, so now we've done all that, and the fork is like not happening over here, and this one's on. So there we go. Awesome. The thing is with the saved R is like, yeah, we're saving R here, but we could really just use R2 instead. So we don't actually need this saved R here. We could use R2. So from, no, init register R2. And then we set, so that's, so R is now saved in R2. And then we set blah, blah, blah. We set this here. What is Bash? Bash is a scripting language that you can, well, let me show you here. So Bash, this is Bash. I mean, or this is Bash script, I guess you could say. That Bash language. So, you know, you can call, so what this does is basically just, you know, if you're using the terminal, if you have the terminal here, you're basically, there's a high chance that you're using Bash here. So you would say like echo hello, it outputs hello. So these, they're the commands, you're executing a command in Bash when you're doing that. And then these Bash files are it's just a file version of that, so you can run a bunch of commands. So if I run this bash bash basic sh, so that's basically what Bash is. So if you know the terminal in Linux, then you sort of know Bash as well. I don't know if that answered the question, your question. I mean, it depends on how much you know. Have you, or okay, so have you used Linux before? Okay. Right, so then in the end, instead of doing this, we could do from location image register R2. Okay. And with that, we actually don't need the saved R anymore. So you can be gone. Oh, thank you very much. Prasad Somvanshi. Sorry if I butchered your name there. But thank you very much for the comment. Okay, yeah, so we don't need to do that. Wait, saved R is R. Right, and now we don't pop twice. Instead, we could just use, I mean, yeah, let's do the same thing here. We use R2. So we store R in R2. R is now the fork thread, and then we save. We restore R back there. Okay. Oh, 1 second here. All right. Closure. What's your age and how many years of experience you have in coding? So I'm almost 4 times 10 years old. Almost. And I have about, I mean, okay, I have about like 10, 11 professional years of experience in coding, in web development. But I have been coding since I was like 10 years old. So if you count that, that's closer to 30 years. But you know, I wasn't super active back then. I wasn't super efficient in learning and everything. But it was fun. I discovered that this is what I want to do when I grow up, basically. Hello, welcome back, Mutasimos. What's up? Are you a developer, Prasad? Sorry, I don't know if is that one name? Is that like your surname or first name, or is that both your names together, or? $10 years? I mean, yeah. 10 years. I got my first web development job. We worked with PHP and Angular 1. And TypeScript, I believe. Oh, Prasad is your first name. Okay. Closure. Wait, so you're not used anymore? Okay, we don't even need the context or the closure here. That's great. Okay. Right. Yeah, the pipeline. What else do we need to do? So closure initialization. Okay, so we get the closure instruction set. We actually compile that. We jump back to return address, and then we should be done. Awesome. And I don't think we should do any manual stack address stuff anymore either. So that actually solved. We hit 2 birds in 1 stone there. I'm not sure about this. I have to figure out what's happening here, because I don't remember any of this. We're gonna try and remove these things. All of these things I want to not do manually here. Yeah, there we go. That's all of those. I'm actually Mutasim, but my friend suggested Mutasim for some reason. I'm from Bangladesh. It's a cool country. Anyways, what is it? Yeah, yeah. I don't know much. I don't know. Sorry, I don't know much about that part of the world. I've never been more than. I mean, yeah, that's like a long way from here. Today I am trying to make for loops work. So we got this. Okay, this now works here. This for loop. I'm trying to make nested for loops work because I suspected there was an issue with this because of some compilation issue. So that's what I'm like redoing a little bit of how my closures work. and yeah, so that is what is happening now. Okay, so now is the time to delve into the compile pipeline to fix this here. And yeah, let's see how we can do this. So compile create closure, that's before the fork, and then we have a post fork, and then we have these things that should be the same thing, and then we have all of these. So these really they don't really do anything in our current scope, like in our current set. They actually do things in a separate set, so that should be fine. And then it's like all of this, like instructions before, instructions. I don't actually remember why we have this here. Last closure index, like we don't really, I don't think we even care about this anymore. Why did we have this? I think we wanted to count how many instructions was inserted, but I don't think we need that anymore. Because we're not actually inserting instructions anymore. So I think we can just remove this, everything of these things here. Which is really nice. If that's the case, I think so. We don't need to modify those indexes. I want to learn Python. I know syntax and all basic array type of stuff, but I'm really poor at coding, mainly logic building using coding. Could you help? How did you start from? I can start from scratch. You're 24. I mean, what I did is basically I just looked at resources online. I mean, I've been doing this for a long time, so it's, of course, I will, know how to do things a little bit. But, when you start out, it's just a matter of practice. Okay, so I think that you should find some project that you think is fun to build. Like when I started out, I thought it was fun to build like these text-based adventure games because they help you. It's pretty simple concept. It's pretty simple to program. I mean, relatively. You have to start somewhere. And it also helps you learn a bunch of things, with a lot of things like how computers work and how the terminal works, and you're just starting your journey there, and string manipulation. But you also it also helps to make you learn the things, the just the basics of general programming, because it doesn't really matter which programming language you pick. A lot of them have the same concepts, for loops, if statements, variables, functions, a lot of features are the same. So if you learn them in one language, you can bring them to other languages as well. But you should focus on one language to start with, I think, because otherwise it's going to be too much information, too confusing otherwise. So start with one language. If you want to learn Python, that's great, because Python is very easy, I would say, an easy language to start with, because it's dynamically typed, so you don't need to worry about types that much. You can I think you can even reassign something to be some other type. It has you don't need something that's you can just write code directly. It just executes the code directly as well. So I think Python is a very good choice to start with. But other than that, just try to build projects that you find fun. I know that in the start it's gonna be very hard to kind of conceptualize how to actually solve problems, because you just simply don't know, and you need to learn how to do that. Because I remember that was the most hard thing in the beginning was okay, well, I know kind of what I want to do, but I have no idea where to begin at all. So it's I feel like when you got a good grip on that, well, the thing is that's always gonna be a problem, but that's gonna be easier and easier the more you practice and the more you learn what you can do. So but do tutorials and try to understand what's going on, and do projects. basically. I don't know. Listen, I'm not a teacher, but this is how I did it. This is how I kind of learned. And I mean, I've tried to teach people programming, but it's super hard because if you're not familiar, it's like there's so much information, and sometimes it just doesn't fit right in the mind how to do things, how to figure stuff out, how to solve problems. I mean, one major skill set that you're gonna learn is like how to think of a problem and then break it down into smaller pieces, and then try to solve those in a sequence, basically. That is a major thing that you need to learn when you start out, and keep learning all throughout. So yeah. But yeah, I think a good way also is to actually go to some kind of some course, get some feedback. Maybe you can ask questions to a teacher or something. And then just a bunch of practice. Just practice, and then eventually you'll get it. But yeah, you'll never run. I'll tell you this: you'll never run out of things to learn when it comes to programming. Like, there's always more things to learn. You are a transpiler, Mutasimos. Okay. You converted code from C# and Python to Rust, and it was scary. Yeah, a manual transpiler. Or a translator. From C# and Python to Rust. Interesting. What kind of project was that? No field name index instruct closure context. That is correct. So closure is we could just do like return address, I guess, instead. Same thing here. I'm putting F in there to format, because this type has like a format function. This type here has a format function, and this would determine how to format the value as a string, which is, I think that's one of the cool things with Zig, how they deal with formatting. Because it's really simple, and it uses the writer interface as well, which is really cool, because then it can work. It works with anything, basically. You can format it. Yeah, it just works. Okay, so we've done all the compiler errors. So if we run this now, of course it will work first time. Or not. Okay, let's just see if this works right now, because we've done some changes. Okay. So this doesn't actually work. It's kind of weird, because we kind of get the same kind of error. This is going to be a hassle to debug, because there's a lot of things happening. Okay, so we've got 5.1d. I'm almost tempted to use AI here to figure this out for me. Have you heard of the game called Cell Machine? It's a dying already dead game, and I was creating a clone for it in Rust. Cell Machine? No? but it sounds interesting. Cell machine. Arrange cells. Build machines. Destroy. Wait. Is it... Could... What do you mean it's dead? Like it doesn't get like updates, or is it like open source? I don't understand the code with my original programs Cell Machine because their code is even more seldom. Okay. Do you follow AI models like ideas like Cursor, or do you completely try to avoid it? It's a bit of both. Like I try to do a lot of things. Like it depends on the project, I would say. Like this project, I want to do a lot of things myself because I do find it interesting and fun to actually do. Because it's like programming is kind of my hobby as well. But sometimes, like for this project, it's gone on pretty long, and it went from being pure fun to now being more of a chore to do some of the things. And I basically just want it to work now and be done with it, basically. So then I can use AI. Like for now, for example, let's just use AI here. Or should we? I mean, I can do this. I can ask AI here to say investigate the error we get when running Runic. Actually, maybe we should have these things. And then IR4. Suggest some solutions. Suggest a solution to this issue if you can find it. Okay. So I will just have that working in the background, and then in the meantime I can just, you know, try to do it myself. I don't remember where it was now. Set 4 iterations. Okay. Well, actually, the first thing that I want to check is if the labels are correct now. This seems correct. Okay, it doesn't get updates and community forgot about it. Cell Machine, no matter different community versions they were made during 2020. So is this the same Cell Machine that I'm finding here on itch? On itch.io? Or okay, anyway. That looks correct. After looks correct as well. Although I am... Okay, yeah, and then we got this one. That also looks correct, yes. And then we have this. Okay, this one is not correct. Okay, this one is not correct. It should be at a compare. It should actually be... Wait, where is this? Why is it up here? It's the wrong set. Ah. Wait, why are you changing things? God damn it. What? Why is it changing things? Oh, this doesn't do anything. No, no, stop, 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 stop. Okay, this is why I don't... Man, I thought that if you frame it like this, suggest a solution, that it wouldn't actually like do any code changes. It would just try to analyze. Yeah, whatever. I mean, yeah, AI does work very well as most of the time. Like it is actually very helpful sometimes. It's just that sometimes it just doesn't do what you want it to do. And then it's super frustrating because you're wasting a bunch of tokens and time and money on it. Cell Machine was made by Sam Hogan for GMTK Game Jam. GMTK Game Jam. Yeah, I mean, I'm working with Codex, and it does work it works pretty well. But it is a little bit different than Claude from what I understand. Like Claude asks more questions, I think. Something like that. Like it wants more feedback. While Codex just goes ahead and does things, basically. But you can't tell it to say, like, you can't tell it to be, if you're very explicit. I do want to test our Claude out. It's just I don't know. I already pay for a subscription to ChatGPT, and Codex is like part of that. So I don't know. I feel like I want to use that, you know. Yeah, the Cell Machine game. So it looks like the same game. Where is it on? Is it on GitHub or something? Or because it looks like it's on itch.io. Like, where did you find the source code? Okay. How does your IO language work? For example, does it store data in memories like real CPU? Is the CPU very much fine to do? Basically, okay. So what we have is we have the evaluator. Let's see. So here's everything sort of that we store to run the program in the IR. So we have like a shared context that includes things like the instructions, read-only data, and okay, so basically how it works is that I'm compiling a SIG program that interprets the IR, and then I'm using this context to keep track of everything that's happening. So this includes like in memory, read-only memory. It includes dynamic memory, heap and the stack, which is all like virtual inside this context struct here. And then we have threads. We have pipes, which are basically kind of like in-memory sort of pipes that can either buffer to memory, or it can also redirect to like other outputs like standard out or standard error or something like that. It can also read from standard in. We have closables, which are like processes that you can like close, so to speak, like exit. And that's sort of it. And then this keeps track of which thread is the current thread that's gonna run the next instruction. Each thread also has a context, and they have, so this is the thread context here. It has the instruction counter, where is this thread currently executing. It has a private stack, and then it has the registers. So we have a stack frame register, two like sort of general purpose registers, process. I'm not sure if we use this. I think this is like, the idea of this was to bound a thread to a process, but I'm not sure if we even use this, to be honest. It's like a remnant. And then also a thread can go to sleep to wait for another thread to exit before this one continues. So yeah, it's a whole machinery to be able to kind of run things in parallel almost. I know that's a loaded word when it comes to programming, but it's like concurrent or parallel, whatever. It's not run at the exact same time, but it's like a round robin system. So if you have 10 threads, each thread gets a turn. So basically you step through first. The first thread runs its instruction, then you switch to the next thread, you step again, the next thread is doing its thing, and so on. Try Claude. I swear, use Claude Opus 4.6 once, you will be really amazed. I'm a Gen AI developer. What does that mean? I mean, does it just mean that you're learning programming while AI exists? I know real coders don't prefer this. Just try once. Yeah, I mean, I'm fully aware how good like AI programming is right now. Like I can use Codex to build me. I'm actually using Codex right now to build me. I'm building an application that I'm gonna use to build other applications with generative AI. Okay, I mean, I think the term is vibe coder. No, I don't know. Okay, so they found a politically correct term for that. No, but I mean, okay. So I would say like this. I think AI has made a lot of progress, but right now you can't replace like all programmers with AI, because it can still, there's a lot of things it can't do. And I mean, you need someone with knowledge about what is actually happening to be able to verify that things are actually working as they should. So, you know, for now, programmers still need to exist, I guess. I mean, I think they should always exist, because someone needs to actually know how AI works as well. I mean, what if we lose the ability to know what AI is doing? Like, let's say AI gets so good that we don't even need any programmers or anyone knowing anything about computers anymore, because AI can just solve everything. What's gonna happen then? Yeah, I'm not even sure if that's feasible, but you know, it's very impressive what it can do right now. So at some point, I think that I mean, yeah, it's gonna take over some things, but there's also the question of like energy and all that. But yeah, anyway. Okay. CMMM implemented saving and copy C# code from CMMM plus MM. Wait. Original same machine didn't have saving implemented, but a different game level made a clone named CMMM plus MM based on CMMM plus, which is based on CMMM, which is inspired from Cell Machine. Wow, okay. Wow, I didn't realize there was a whole like arc there for Cell Machine. I mean, if we just search for it, the first thing it comes up is Cell Machine by Sam Hogan on itch.io. Where where do I find the source code? CMMM plus MM. Is it Mystic Mod? View project on Scratch. Is it made in Scratch? No. But you said C# and Python. I'm just trying to figure out where the source code is. Where did you find the source code? Because I want to look at it. Okay, where were we? Compiler. I did figure out the issue. I just don't remember what the issue was right now. Yeah, the label was not correct, right? The label was not correct. But why? But why? Also, I want to try IR pipeline basic. I want to try this. Okay, so pipelines work now. Great. They were actually broken before, but now they work. Okay, cool. So what? Why is the label wrong? That's the question. Oh yeah, it was correct, but it was the wrong set. So why is it the wrong set? This should be correct here. The return, the closure return is correct. But this one, no, not this one. Where is it? This one. The jump back to the return address. No, wait, that was not it. No, it was the for label that was wrong. Alright, or... For 6. Yeah, it was at a 1E. And 1E is correct over here, but this is like the wrong set. So for some reason, this is wrong. Okay. Label 4. Strange. Very strange. This should be correct. CMMM plus MM refers to Cell Machine Mystic Mod plus Millenacos mod. Oh. Cell machine Millenacos mod. Millenacos Mystic. Okay. Cell machine Mystic mod plus Millenacos mod. A CMMM plus MM is a mod for the popular Cell machine Mystic mod CMMM plus, which adds more cells, fixes bugs, and adds new songs and quality of life features, online mode, and a lot more. Wow. I mean, I don't know if I would call that a mod. I would call that like a, I don't know, DLC. No, but I don't know. Okay, so this is the one that could have maybe some code somewhere. Source. Okay, so you can just download the source here. Cool. All right, I'll check that out sometime. Hey, cool guy, welcome back. Is there any impact of war on your country? Not from what I've noticed. Not more than what you hear from on the news. Oh, the prices. Yeah, okay, well, I have like, yeah, maybe maybe gas prices going up. I don't actually know. Har bensinpriser ökat? Okay. Yeah, because I haven't what do you call it when you refill fuel on the car? I haven't done that in a while, so I don't really know what the price is right now. But it was like, I don't know, maybe 14 Swedish crowns per liter some time ago. So we'll see if it's more than that. That's about, I don't know, €1.5 euro something. Dollars. Everything skyrocketed. Prices went 100 times. What the hell? 100 times? Is that? I mean, are you exaggerating? Because that is. I mean, that's impossible to buy any food then. A lot of gas stations now in Bangladesh only give gas to army people. Wow. So is Bangladesh also part of, like, all they also dragged into this here? Or are you, like, okay. I don't know. I just don't like what's happening. Of course. I just heard, yeah, I've actually, I don't really pay that much attention to those kinds of news right now. I don't have the energy for that. Okay, so let's see. Not really involved in war, just that there's lower amount of fuel. Oh, okay, I see. Yeah, it sucks. It is Great. Yeah, I need to eat something soon, so I'll probably have to go here soon. I'm not sure if we're gonna be able to fix this. I mean, it feels like a very small fix to do that. I just don't understand why it's the wrong set. That is very strange. Like, why would this be the wrong set? Is it the same with the after? See, this is correct. This looks correct here. So that is very strange. Why is this a different set? What the hell? It's set 0. Set label to be address. That's just the number. What the hell? I'm confused. Okay, it's assumed to be the same set, I guess. But this should be the correct set. I'm so confused. You know what? I mean, it might... It could be a bug in displaying the label, but... Hello, Penguin. Welcome back. Like if we go to 4, 6. So this is at 1E. And when we jump to it, so this is 539. Oh, we get an error even before that. I think this is the same issue, perhaps. It's like jumping back to a bad place. Okay, what if we do this? Do we still get an issue? Yes. Because what I want to do is just simplify this a little bit so that we can, you know, more easily try to see what's going on. Also these ones, main closure return. Yeah, that looks correct. That also looks correct. But this one does not look correct. What the hell? Yeah, that is not correct. So both 4, 5 and closure return 7 is like wrong. This is also wrong. Are all of these in set 0? Yes. This seems correct though. Okay. Maybe there is something wrong with the labels. I mean, obviously there's something wrong, but maybe there's something making them not get their actual instruction set that they should have. Because we're just taking whatever we should be having at the moment. I mean, yeah, it could also be a display issue, but I'll just log this out. Whoops. For label should have a, I think we have a format function on this one. Yeah. See? It does have the correct set here. But when we look at it, it's like in set 0. This does say 7. No, that's 0. Okay, let's try this one. So 8, 6. 8, 6, 8, 6. No, we don't get there. We get the 4 after 4. Which is also wrong. Because it should be set 5. Okay, it could be a display issue. It looks like this is correct. The actual set is correct. But the display here is wrong. So it looks like, okay, yeah, I think it's just a display issue. Where is that happening? I believe maybe the runner, perhaps. Yeah, we're going through the labels. Wait, this is weird. Why is there only one address? There should be like an instruction set as well. I am confused. Counter? No, that doesn't matter. Yeah, I think this is just wrong here. This should be like a resolved instruction address. So weird that this is like this, because I would assume this is also that has some kind of evaluation in the actual runner as well, not just a display. Less than, so we're sorting. Wait. What the hell? Well, I guess we could do like set first. So if the set is less than and okay, well, let's get like left right. So if the instruction set is less than, no, then it's just true. Or if it's equal and the address is less than the right address. So this has like priority. If this is true, it doesn't matter what this is. So it's either the set is less, or if the set is equal, otherwise the set is more, so it's false. But if the set is equal and the local address is less, yeah. Okay. All right, what the hell is going on now? Compiler. Right. So this is kind of weird. Like, I don't understand. What is this returning? An instruction address, right? It's just that this label, we need to, and then the address needs to include now the instruction set. Yeah, why was that not? No, there should be like an init. Yeah. Okay. So we're using null for labels when they don't have. I think it's when they don't have a known address. Whatever. Let's just call it whatever. But it's actually local. Well, whatever. No. I'll change you as well. And this is basically the same thing, except we have labels that are named, and we turn this, and we do set instead. Okay. Expected type is found instruction address. Sole address. Okay, I might have messed this up here. Oh yeah, now I remember. God damn it. Because the thing is, okay. Instruction address was like composed of instruction set and then some kind of description of the local like thing. So we have like, okay, you have a relative, which doesn't really make sense. Well, it's relative to the current thread counter, I guess. Or I mean instruction counter. And then the absolute, and then you have the label, which then would store the set. But where would we get the instruction set? Yeah, I'm confused. Like this should include the instruction set, because otherwise we don't know which label we should show. It's like the labels themselves don't hold all the information. Like the set is actually stored somewhere else, which doesn't really make sense in a way. Yeah, they need to have an instruction set. How would we otherwise know? No, yeah, okay. So the instructions themselves do have the information, but the labels do not. So, but yeah, I'm just gonna add it to the label, whatever. So now if it's a label, it's weird. So we would get the local address. But actually we would just return this. Yeah. And also the format function needs to change. Because it's like this could now actually include, no, that's just a key. Okay, never mind. Okay, so now here we have both the address and the instruction or set, and so we can see this is So if this is I, and if this is instruction no. Log instruction. Right, we need to pass instruction set here as well. And we want to check, are you equal to instruction set? Okay, there we go. Why do we even need this? It's to print it, okay. Okay, so there we go. Now, back to this. Look at 4, 5, I guess. Okay, now it's at set 5. Good. And what else? After. Yeah, that looks good. And this one also looks good. Then we have closure return. Set 7, great. That looks correct. That looks correct. That looks correct. Okay. Okay, so it's just a display issue. Because if we run this, we still get an issue here. I'll just remove the logs there. So what is what? What is happening? (5a). So we're trying to set 4 iterations. Okay, you are failing directly there. First iteration, 5a. Set 4 iterations equals R2. So I'm guessing, yeah, R2 cannot be the reference because it's set to 3. This comes from 4, line 4, 3. So it's the inner for loop here. R2 is set to source plus 5. No, the stack. So this. Yeah, that's the length. Okay, so 4 iterations, that should not be dereferenced. Maybe I changed something here to R2 is equal to source ref dereferenced. I think we did this to make sure it was like double dereferenced. So there's something wrong with that pointer. I'm confused. The source actually. Okay, so the source is wrong, which is this R here. There might be one too many dereferencing going on when referring to this R. What if we make it into mutable? Will that work? No. Alright. Yeah, I think the issue is that when we're I don't think it's the for loop. It's not the for loop that's the issue. It's like, let's say we want to refer to R from here. Let's do like, I don't know, some kind of weird, like this. I think this is still the error, yes. So it's not that we have an inner for loop, it's that we're referring to this array variable from within this scope over here, which is passed through the thing here. So what if we remove this? Will this be in the same closure? No, still the same issue there. So even when we remove the block, we still have the same issue. So we kind of simplified the problem here a little bit. And I believe, yeah, there's some kind of issue when we refer to this from here. It's actually threaded through a bunch of closures to point to the same place where this is stored. But somewhere along the way there's like a double dereference, one too many dereferencing, which make this value only become like a 3 and not a pointer. So I'm gonna write this down because I'm not gonna solve this right now. Issue here with referencing a closure variable. It seems to dereference too many times when we try to access it in the inner closure. Alright, but that's gonna be it for this time. Yeah, I think we did actually do a lot of nice stuff. I mean, it wasn't really that visible from, you know, making new code work, but it's basically, actually the closures are compiled in a way better way, and we don't need to manually worry about changing the relative stack address or having instruction addresses in the wrong place because of doing some weird insert of instructions. So it's way more cleanly compiled now with the closures. So I really like that fix we did there, which was necessary as well to have to make this work here. But
We still have an issue with that I said here, that we're referring to like a closure variable from within an inner nested closure. For some reason the array gets dereferenced too many times, and we end up with the length of the array instead of the pointer to the array. So yeah, we need to fix that issue, but I think once we've done that, for loops look pretty stable, and then we can move on to supporting multiple arrays and multiple captures, and also ranges. And after that, the for loops are basically done. So yeah, very good session today. So yeah, that's gonna be it for this time. I hope you have a nice day, and I'll see you tomorrow probably.